All right, let's try this. Let's do a dry run. We're going to see how this works. If this works, we'll do this tomorrow for a sub. But we're going to do Grade 8, Unit 5, Lesson 7, Connecting Representations of Functions. So we briefly discussed, but today we're going to connect them all because we've looked at tables, we looked at equations, we've looked at graphs, and then also just a story can also be a function. Now we're going to look at them and be able to compare them rather than just look at one or the other. We're going to look at two functions and compare them and see how they add up to one another, or better yet, just compare. So it says I can compare the inputs and outputs of functions that are represented in different ways. In other words, should be able to look at a table of a function and look at a graph and then compare. Doesn't necessarily mean they're going to have the same numbers, or we could say, oh, this person's running faster, or this person's drinking their milkshake slower, or who knows. But so let's look at the warm-up. It says, which are the same, which are the different? Here are three different ways of representing the functions. How are they alike? How are they different? So here is a function, it's an equation. Here is a function, it's a graph. Here's a different function. It's a table. So how are these alike? How are they different? I don't know if you heard what I just said, but I kind of just told you how they're different, right? Then we can look and see how are they alike. Well, how are we going to be able to compare these numbers if they're all represented differently? One's an equation, one's a graph, one is a table. Well, if we notice, this is a point right here where x equals 1 and y equals 2. So if we kept going up, we're going to see another point here where it says x equals 2 and y equals 4. And you might be looking closely too, and I shouldn't be saying x or y. Maybe I should be saying a and b. Here's y and x, and this is p and q. So that's another way they're different. They're using different variables, different letters to represent them all. And I don't know if you're noticing this. If you plug in an x value for this equation, if you get 1, y is 2. If you plug in 2, you get 4. So if we wanted to, we could make a table of x and y, and we got 1 and 2. We got 2 and 4. As you can guess, 3 would probably be 6. And you might be noticing, well, what if we just put in x? What is x? If I did right divided by left, I get a COP of 2. 2, 4 divided by 2, 6 divided by 3. So this is 2x. You're going to notice, well, y equals 2x. This is the same, other than it's different letters. So let's look at this equation. Here, if I input 1, I'm getting a negative 2. Here, if I input 2, I get a negative 4. 1 times 2 is not 2. 2 times 2 is not negative 4. So this is not the same equation. Believe it or not, this one and this one are the same function. This one, you should notice they're multiplying the top not by 2, but by negative 2. Q, whatever Q is whatever P is times a negative 2. Or what we would say is Q equals a negative 2P is just typically how we write it. So that's how they're different, so to speak. We could say they're alike, well, because the top two are the same function, believe it or not. They look different, but they're actually the same function. And the bottom one is a table that actually is not 2, but negative 2. So let's see how that works. And we're going to call it good for the warm-up. How do I stop this thing?